All right, in this video, I'm going to be going through notes for the types of chemical reactions. There's really not a lot of examples or writing that I'm going to do on here, so I'm going to go through this kind of quickly. It's going to be a short video, but I would recommend pausing it, taking a look, writing down the types of reactions, and perhaps the example that I give. So let's go. Types of chemical reactions, there are 6 main types that we talk about in general chemistry. There's lots and lots more if you get into especially like organic chemistry. There are many types of reactions. Some of them, or quite a few of them, are named after people. In fact, there is a chemical reaction in organic chemistry that is named after a former UVM professor. So one of the UVM professors, he was still there working as a professor emeritus when I went to UVM. He has a type of chemical reaction named after him. However, his name is not on this list because his name was not John Decomposition or Bob Metathesis. So yeah, you can look that up, see if you can find what reaction is named after a former UVM professor. So here's the list. We're going to go through each of them, and I will give an example of each. But before we get to that, some vocab that I want us all to remember. That one reaction is often abbreviated as RXN. I will abbreviate it as that many times, so hopefully you all remember that. Reactants, those are the chemicals that are taking part in the chemical reaction. The products are the chemicals formed during the reaction. Balancing numbers indicate the number of moles of a chemical involved in the reaction. And a little more vocab. Right, as most chemical reactions take place in solution, right, usually in water, we're going to review some terms that go along with that. So a solution is a homogeneous mixture of 2 or more substances. Hopefully we all remember what the term homogeneous means. Solvent, right, this is part of a solution. It is the substance present in the greatest quantity, right? Or you can think about it as the thing doing the dissolving in a solution. Solute, that is the thing being dissolved. Okay, even more vocab. We'll talk much more about electrolytes in other units, but I want to introduce this vocab here. Electrolyte is a solution that is electrically conductive due to the presence of ions. So the electrical conductivity is a result of the movement of ions, not the direct movement of electrons. And you have both strong and weak electrolytes. All right, strong electrolytes, things that completely dissociate or dissolve in solution, and weak electrolytes, they do not completely dissociate or dissolve in solution, which means that only a small portion of what you put into a solution actually dissolves. So you'll have solid left in there that is undissolved. Okay, on to the examples here. So the first is synthesis. The basic definition is when 2 or more chemicals combine to form a new chemical compound. The general format is A plus B forms AB. And the example is iron and oxygen forming iron oxide. Decomposition. This is when a chemical compound breaks down into its chemical components and or smaller molecules. The general format would be AB forms A plus B. An example of this is magnesium oxide breaking down into magnesium and oxygen. Single replacement. This is when an element replaces or trades places with one of the elements in a chemical compound to form a new compound. Whether or not this will occur depends on the relative strength of the elements. And see my note there, it says C activity series. So take a look at the activity series. The general format would be A plus BC forms AC plus B. And an example of this that I think we saw last year, maybe not. If not, we can take a look at it again, maybe. Zinc reacting with hydrochloric acid, right? Zinc replaces the hydrogen in that compound, forming zinc chloride and then hydrogen gas. And then, of course, if there is a single replacement, there must be a double replacement. This is when two chemical compounds essentially trade partners. I know you can't see me making the air quotes there, but I made them anyway. And that's going to form two new compounds. As these usually take place in solution and form a precipitate, solubility rules can be used to determine if the reaction will occur. Here's a hint. You should be memorizing some basic solubility rules. So, take a look at those. Memorize your basic solubility rules. The general format of double replacement, that would be AB plus CD forms AD plus CB. And here the example is silver nitrate and sodium chloride forming silver chloride and sodium nitrate. By the way, in this reaction, silver chloride is going to be your precipitate. It will form a solid when you mix these two solutions together. Sodium nitrate soluble, so it's still going to be in solution. Okay, then combustion. Here's one we are all familiar with, right? Combustion. This is when a hydrocarbon reacts with oxygen to specifically form carbon dioxide and water, right? So you always have the form of some hydrocarbon reacting with oxygen to form carbon dioxide and water. That is what all combustion reactions will look like. That is always combustion reaction. And if you notice, right, thinking back to bio, this equation should look familiar, because if you put this chemical in here, right, you have the formula for cellular respiration. And going the other way, you have the formula for photosynthesis. So cellular respiration, what's going on in your body right now, is a form of a combustion reaction. And so here we have our example. This is propane. Yeah, propane combusting to form carbon dioxide and water. Then we have our neutralization reaction. This is a very particular type of double replacement that occurs between an acid and a base, and it produces water and salt. And when I say salt, I don't mean like table salt that you put on your food. Salt is ionic compound, right? That's just another word for an ionic compound. And so here, right, they're trading partners. Sulfate goes with sodium, hydroxide goes with hydrogen. You get water, you get sodium sulfate. That is a neutralization reaction. Okay, so that's it for this video. Just remember, chemical reactions involve the process of reactants going through a chemical change to form products. The type of reaction is determined by the identity and number of the products and reactants. And by knowing the types of reactions and the reactants present, you can predict the products of a reaction. Thanks, and we'll see you in class.